I think now we can start our discussion. So please feel free to write your questions in the chat, or if you want to just raise your hand and then ask the questions, please feel free. So I invite the other panelists to our session, to start. So we have a question from Irfan. Yeah, Irfan, you can go ahead.
Hi, Gracieli.
Hey, hi.
Thanks so much for the presentation. I have a question about the ISPD 2018 and 19 benchmarks.
Yeah.
During my PhD, I was pleased to work with these benchmarks, and I learned a lot from 20 benchmarks that were released by ISPD. I have a question. So most of the benchmarks are from technology node of 32 nanometers.
Yeah.
So this is the technology node that industry achieved at 10 years ago. So can we simply say that academic is 10 years behind the industry? Can you comment on the gap between academic research and industry needs? Because right now we see that we are talking about 7 nanometers and those.
Yeah, we are talking about those new nodes. Yeah, I think this is a very hard thing. I think what we try to do with the benchmarks was to bring some of the rules that are in the new technology nodes to an old technology node that was able to be published. So in that way, it's still it's an older technology node, but it's getting the new challenges. So you can still do some very new research based on that, because the challenges are there. But I understand your concern about the new technology nodes, and that is something I don't know how the foundries, because these come to foundries, how they are delivering all of these rules. We are also under many NDAs about it. So, but I think the research, it's we depend on this research, we depend on the new students and professors to grow up our knowledge and our ideas. And I appreciate everybody that is working on this. But I think what we try to do is to bring a little bit of what we have in the new technology nodes using an older technology node. So you can still feel the challenges on that.
So it means that it can be kind of scaled to.
Yeah, it can be kind of scaled. Yeah.
Makes sense. Thank you so
much. Sure. Yeah, please feel free to ask questions. Let's see.
Can I make a comment here?
Yeah.
I see. And I think Irfan had a question, right? So this is maybe a little bit philosophical, right? Academic versus industry research. In particular for this routing, right? Really advanced technology nodes, right? 5 nanometer, 3 nanometer. So in university, right, we definitely cannot have this kind of really advanced technology nodes unless you work really closely with industry partner, maybe send the students to company for intern, then the students can have some access, right? But I would say that even, let's say, we don't have those advanced technology nodes. I mean, yeah, as I think Gracieli mentioned, right? So one thing our university is to train students. Another is we can have. Another.
Oh, I think we need to mute. Okay, that's fine.
Okay. Another thing, right? I guess we shouldn't be totally discouraged that hey, we're behind the industry or something, right? I guess one advantage of university research is that we can get some novel approach, right? That kind of industry folks, yeah, sure, they have the most advanced technology nodes, but they're really busy debugging and migrating their old legacy code or something like that, right, to the newest node. So in that sense, university research, of course, we cannot compete with them in terms of the most advanced technology nodes, but we could provide interesting food for thought. Right?
Yeah, that's true. You provide your advanced in ideas and what you are researching. Those are really a great thing we have, and many things you don't need really to do in 2 or 3 nanometers, you can do in another technology and that will be applied. So yes, I totally agree with Professor David.
Thanks.
Thank you so much.
Yeah, we have a question to Professor Evangeline. André, do you want to ask?
I can
okay.
ask. So I'm interested on why the incredible speed up of the maze route. You have stated that it ends up not speeding up the entire routing very much, and I want to understand why.
Yeah, very good question. Yeah, actually, we can see that the speed up in the pure maze routing is very big, right? 100 times. But actually, I should say we are still in a process to have this realized in the whole router. I can tell you, for example, currently, we cannot get a very big speed up because you can see, I mentioned, for example, if you want to route many net, we need to pack the grid lines into a big area, right? And then do the switch. So this step currently is being done on CPU because some of the process, some of the steps is better to be on CPU. So we do this on CPU, but then you need to transfer data between CPU and GPU. So actually now we are thinking of not doing that on CPU, but really moving the things, more things to GPU. So this is can be one of the reasons, and there are some other reasons. For example, as I said, the pattern routing has not yet been parallelized. Okay, it's still on CPU. So you know, for example, 50% of the time is on pattern routing. Even if you can speed up the other 50% to 0, you just get double it, right? I mean, because 50% is not improved. So we need to speed up the whole process. So so that is the second reason. So actually, there are reasons for not seeing the speed up right now, but I think they could be worked on. Yeah. So I hope I answer your question.
Yes, thank you very much.
And then I can see another question about
Shane,
yeah, actually,
yeah, you already had. You can go ahead.
Yeah. Actually, a good question. Actually, I think this is something that we need to think about because, you know, for this parallelization, you can see there are 2 levels. So one is a fine grain level that I explained in the alpha, right? Another level, I think many people know that is we can divide the net into batches, right? If the 2 net, they don't overlap in their bounding box, then we can route them together. So we should also do that. But then if you only route those net which do not overlap in bounding box together, then you will lose information about congestion, right? That means some of the net who overlap with you, they are routed in another kernel, okay? So we need to have some systematic update to some global memory. So after I route this part, I route this this portion of work by this kernel, and then the other kernel, then we need to update to some global memory. Well, actually, this may be something that will affect the speed, but we will see how it could be done in a better way. Yeah. I hope I answer your question about the routing congestion.
Yes, but let me elaborate a little bit more about my question. So I was wondering, don't you think that would be possible to do the first routing, the most parallel routing on GPU, and then use this congestion information to run another parallel routing on GPU, but this time adding weights for the paths to minimize the congestion?
Adding what? The second time adding what? I'm sorry.
Run it once again on GPU, but this time considering the weights about the previous run to as a sort of congestion information.
Adding some cost, I think.
Oh, I see.
As a cost.
Yeah.
Yeah, of course. Yeah, of course we can do that. But now we are looking at, for example, how to speed up the first round, and also how to speed up the second round. Of course, we can do this round by round, right? And then the first round, tell the weight for the second round. This could be done. But now we are looking at, for example, for each round, how we can speed up this process. Yeah.
Thanks.
Thanks.
Yeah, thank you, Ivan. Very cool. So we have a question from Professor Jens. Do you want to ask live, Professor?
Sure, I can do this live. As we all know that PCB benchmarks are really a problem or non-existing. The last speaker elaborated or talked a little bit about these benchmarks that he's going to publish. So I wanted to know a little bit more about this. When and how are they available, and how can others then access them?
Yes, and we are working on this work, and we need because we have many maybe close to 20 PCB design, and we want to release as many PCB design as possible. So we need to discuss with the company, and also we also need to know which kind of information should be removed from the release. So we are working on this, and we plan to release the PCB design in next month. And we also already put the link to the GitHub in the work of this panel. So so please just wait for a moment.
Okay, so I guess it will be GitHub. Thank you very much, and I really encourage you to do this because these benchmarks are really needed. Thank you very much for doing this.
Thank you.
Yeah, thank you. Very good question. I was going to ask a question like for Professor Stephan. So how about your work? Like, I know you work with IBM. Do you have like some benchmarks? Like are you benchmarking at IBM, or how does it work? Like,
yeah, certainly we do benchmarking at IBM, and I mean for timing constraint global routing, that's currently the only benchmarks that we have.
Are they available, or how, like?
Yeah, that is something we would have to negotiate with IBM. I can bring up that discussion there.
I see. So it's not something it's available, like maybe after some time they make it available. It depends on how they are.
I mean, one problem is of course that they don't have a fab any longer as they used to have.
Yeah, yes.
So they cannot make benchmarks based on vendor technology.
True.
Which was different in the past. So that made things much easier when IBM provided a lot of benchmarks. But yeah, sure, good benchmarks would be a nice thing to have, and I will bring that up.
Yeah, I totally understand. Like, because it depends on the foundry, so and that is a lack. Like foundry is not able to really provide it. So yeah, we have the same issue, I think, as well. Wen-Hao, are you doing some multi-threading already in your new algorithms?
Oh, yes. Actually, we recently our 3D IC team recently developed an auto package router, and we also integrate our embedded our multi-threading technique inside. And currently, for some design, we can see when we use 16 thread, we can see 10x speed up for the package routing. So yes, we will ship this feature to our customer very soon in our auto package router.
Oh, that's very cool. And how is the benchmarking? Like, do you have something available for like research?
Actually, I do have planned to probably raise another 3D routing, 3D IC routing contest or package routing contest. But there are some NDA issues we need to resolve first. And also now recently our 3D IC team are very busy, so probably not right now, but I believe sometime in future we may raise a contest for that, and meanwhile release some test case similar to the challenge we are seeing here.
Oh, that's very cool, exciting. So yeah, I thought someone was going to talk. I'm seeing questions here from Brun Prasad. Do you want to ask live, Brun Prasad?
Hi, Gracieli. So the question is, so we have in the advanced nodes at least a lot of rules with exceptions. Those try to capture some sort of increased utilization in routing and placement. So can we expect some sort of contest with rules with these exceptions? Because these are the harder problems that the detailed routers today face.
Yeah, something more in the detail routing. We don't have yet any plan, but I think that should be a very cool thing to do. We need we need people to run the contest, actually. If we find the people to run a contest and do all the benchmarking, I think that's a good idea, actually, because then we can provide more more to academia to research, as we did for the initial detail routing contest. So as far as I know, we don't have any contests being planned, but maybe ICCAD or other conference have something. Yeah, please, if anybody knows, please, yeah, let me know. We have another question to Wen-Hao. Karen, I don't know. Sorry if I didn't say correct. Do you want to speak live or?
Yeah, I think you already asked Wen-Hao about the benchmark. Yeah, I'm asking the same thing. So yeah, I think Wen-Hao already answered my question.
Okay,
Thanks.
okay.
Oh yeah, but I don't think I answered your first part. Because in your question you would like to get me to comment the current status.
Yeah,
actually, yes.
Yeah, I saw your presentation. You mentioned like the technology is evolving very fast, so there will be many changes in the future. So do you comment when it be robust for academia to have a concrete research problem to work on?
Concrete. Okay, first of all, let me introduce what I see here. In the past, when we're talking about 3D IC research, and usually it's just research, college write a paper and some design house write some white paper with 2 or 3 engineer or researcher. But now the 3D IC status in industry, it's happening, it's real. Many different company, foundry, design house, EDA company invest a bunch of people to try to make it happen. And I think this will be we will see some release in the future, some wider paper from different company talking about this solution. So in the industrial world, this is happening, and I think after some real test case generated by design house, and we can and we will I mean, say like an EDA company like Cadence Design Systems, they may have some internal test case created by our internal RD or internal testing team. And after we have this kind of testing toy test case, I think if we want to co-work with college, we can try to simplify those toy test case to illustrate the problem. And then I believe sometime in future, probably 2 or 3 years, college, we can release test case, some toy test case to academia to play with. I think this is what I expect may happen.
Thank you very much.
Thank you.
Thank you. I have a question to Professor David about the benchmarks as well. So for analog design, how is the benchmarking? I'm not so familiar with analog, I'm sorry, but I'm curious to know like how you benchmark, how are like these steps, like I know like you have a lot of cooperation with industry, but
that's a great question, right? Unfortunately for analog, right, there's not this, how should I say, standard benchmarks, you know, like ISPD should have a contest for that. Yeah, we actually, you know, we work with some designers, and they have certain designs, and they even have manual tap out, and then we kind of compare with the manual design, right, as our baseline, right? And we actually released some test case. I think Professor Stephan's group probably also have released something. But yeah, there's not a generally, like, first of all, I guess not so many people are working on analog routing. Right? I guess once I would encourage ISPD to have some maybe analog kind of routing contest, then more teams can work on it, and then we'll have more published, everyone accepted the benchmarks. So yes.
Yeah, I think that's a good idea. Yeah, maybe like Professor David, Professor Zi-Shen can help like to get some people to organize the contest, because I think it's a good idea, really. And I'm seeing more and more works on these related to this. So
yeah, actually, Mark, Professor Mark also.
Mark, yes, that's good.
Oh, he's sleeping now, I guess. Okay. Yeah.
No, that's good. Yeah, thank you, Professor David. There is a question here to Professor Evangeline. Oh, it's from Stephan.
Yeah, maybe I can phrase it. So to Evangeline, so first, I really like that work, and I really like to see more progress there. The question I have is because I feel that we still not leverage all the CPU cores that our modern server systems have today. So how many cores did you use for your reference flow?
On CPU, we use multi-thread, 8-thread we use. And then the one that I mentioned in the talk, we on GPU, which is on the 3090, the RTX GPU on one GPU. So this yeah, actually I agree that actually I think there should be a lot more can be done in terms of like parallel and using the resources. Yeah.
Good, thank you. It's good we are getting ideas for the research as we are growing. So we have a question from Andre. Do you want to make it live, Andre? Oh, Professor. Yeah, you can go ahead, Stephan.
Yeah, or let him phrase the question first, then.
Yeah, no problem.
Sure. So I'm wondering if the panelists can give their opinion on SAT-based routers. And if they think they envision a partition-based or sliding window-based SAT router, because it can handle special cases by construction very easily, which has been increasingly difficult for standard algorithms, right? So I wanted to know the opinion on that. And Professor Andrew Chang already gave his opinion on the topic, yes. So.
Yeah, Professor Andrew. Yeah, Stephan, you can go ahead. Sorry.
Yeah, so I think there was so much progress in SAT solving in the last decade that there's a lot of possibilities. Probably today rather to resolve local routing problems, whether it be DRC or just overflow. At a local stage, I see a lot of potential. Globally, I think we still want to minimize wire length or other objectives, and there it's a bit problematic to integrate them into a SAT solver at a global stage.
Yeah, actually, I think the SAT is a good way to solve detailed routing, because you can formulate many detailed violation rule constraint to the SAT. But of course, I'm looking forward. Maybe SAT can be solved. I mean, recently there are many advancements in SAT solving already, but I think hopefully it can be even more speed up by using GPU or parallel. Yeah. So actually, yeah. With that, I think it will be good to see whether detailed routing can be improved further.
But Professor Evangeline, do you mean a GPU-powered SAT solver?
Right.
Yeah.
That's a good idea.
Yeah.
Yeah, I think Evangeline has a great point, right? Yeah, I think the main problem for SAT SMT based for big routing problems is the scalability, right? Actually, my student Chang, he was a speaker in the previous session, right? We worked with NVIDIA, right? And for that placement, right, in his flow, right, he has some placement. Then he used SMT, but for routing, he didn't really use SMT, right? And we had some discussion, right? And it was saying, yeah, mainly is a scalability issue, but yeah, if we can solve the scalability issue, I think it's very promising. Right?
Yeah, that's. Anybody else wants to comment? Maybe Professor Andrew, do you want to comment live? I saw like your comment in the chat.
Oh, sure. I had a follow-up actually to that discussion. What scale of solvable by SAT would be useful? For example, bottom 8 layers and 200 tracks by 200 tracks as a box size. If that could be solved in, let's say, 10 seconds and you would have a yes or no answer, is it doable or not? I think people would be extremely excited. Or do you need something bigger or faster? Can you comment?
Yeah, actually, I think if we can solve like 240 track by 240 track big layers in 10 seconds, that's very exciting. But what is enough? I think it's hard to say. But currently, I think if we apply SAT, we can just really maybe if we think about 1,000 track times 1,000 track, then we may need to divide into maybe just 10 track or 20 track, square shape like that. I think it may be doable, but that will be too many instances, right? So it's hard to say. It's hard to say what is enough. I don't have an answer for that.
Yeah, I just deliberately made the number large, actually,
right.
because, you know, for me, 100 by 100 would be really amazing too. So.
Right. I think now it's like maybe 20 times 20 is doable. I guess, wild guess. If you but then now we are talking about like 1,000 times 1,000, right? In detail routing. So yeah, I don't know.
Yeah, some interesting ideas to to check, I think, and to have research on it. And I'm seeing Professor Andrew also asked a future contest direction of DR where there are simply many complex forbidding patterns. Seems to take DR into a different arena than, for example, DRC exceptions or more complex rules. Yeah, that's true. Like there are many forbidding patterns, like it's getting into the complexity of our routing, and that will give also a good contest, I think, to be done. Like maybe the new guys in the routing things can help to get this. I think one question I have, like, and I'm curious, is about how can we get more people working in routing? Because I think we want to have more research, we want to have more ideas, and how can we help on that? Like, how can we get more students interested in routing, like in helping resolve these issues?
Okay. I think from companies aspect, I may say if we pay routing guys better salary, we will have more people working for routing, and this is happening. And if you have very good routing knowledge skill, you will be very valuable in EDA industry, and you will be well treated. Yeah, this is my short answer.
Yeah,
oh, and another one comment. Yeah, because compared to other stage like timing optimization, placement, or floor plan, or even clock synthesis, routing has a very dominant engine, a routing engine like a mass router. Actually, if you have a good mass router, you can run say 100 times faster than another router with bad mass routing engine. So if you have good routing skill and knowledge, you can make your tool has a big advantage than others. But if you are working on other problem, I'm not sure. Or let me give some number. For example, a industrial router probably mass routing take 90% runtime. If you make 2x improvement in your mass router, your routing tool get near almost 2x faster. But if you working on other engines, sometimes the other engine may have several small pieces and come from different people, and you make one piece 10x faster. If you look at entire engine, probably you just contribute 2% of runtime improvement, something like that. So I think doing routing is a very good investment.
Yeah, true.
So when you say 100x, that's huge. So is this mostly, when you're dealing with all the DRC checking, stuff like that, not global, right? I mean, if it is a grid-based, I don't think a lousy implementation will be 100x slower.
Because I am working on package routing.
Oh, packages.
Yeah, I am using, actually, I think a routing, even digital router can have 10x, even 100x speed up in terms of mass routing. Yes, and definitely yes. If there is also part like DRC checking and some processing step, and it sometimes also take about 20% of runtime. Depends, design by design. So my number may not be 100% correct. It's design by design based on the rule how rule complicate. But in the package routing problem I'm working on, actually we make a differentiation in our engine. Previously, actually, if we are familiar with some research paper for the package routing, like for example, escape routing, escape from the package inside to outside, this kind of, some paper use SAT, some paper use ILP, some paper use reliable route mass routing. And we try internally, we try several different methods, and eventually we come out our new innovation, which is 100x faster, even 1000x faster than existing algorithm. With this speed runtime, we make package routing, auto package routing engine productionable, and then we make this happen. Yes.
Very nice. Thanks.
Thank you. Thank you.
Yeah, thank you, Wen-Hao. So you like others as professors, like any idea on how we can get more students working on routing? How are like your groups now? Like, do you have some people working on it, or?
I mean, here in Bonn, probably half of the people working in VLSI design are working in routing. So
that's good.
The biggest sub-project, I would say.
That is a very good news. How about Evangeline in Hong Kong?
Yeah. Actually, some 2 to 3 students are working on routing.
Oh, that's good. That's good.
Yeah, actually, I think global routing is easier to work on, and actually, it will be if there are more information, more benchmarks, or more information for detailed routing. Actually, it can. I think it will definitely help to boost the research on detailed routing. I think, which is very much needed actually. Right? Detailed routing is very slow.
Yeah.
And
It's too many details, like it needs to consider
Right.
action. Yeah, I understand. Yeah.
So the context is very good. I mean, a few years back, right? The detail routing, actually many work coming out.
Yeah. At least it's boosting some more works like with the benchmarks. So I think that's good. How about Yih-Lang, like in Taiwan? How is it?
Yeah, and actually more than half of my students they all work on routing, but for my case and my research direction is totally depend on what kind of projects I'm working on, and so in recent years and most projects in my labs are relatives with the routing in several areas, such as global routing and the cell routing and the PCB routing, and so this is the main reason why more than half of my students work on routing. Yeah.
Oh, that's very good news. Like it. How about you, Professor David?
I probably have 2 to 3 students working on routing, right? Mostly analog routing, but previously, of course, we worked on global routing and also using some AI technique to help routing guidance. And well, I would say some of this not necessarily directly routing, but routing aware placement, right? Even for FPGA, I have some students working on FPGA, but that's also routing, right?
Yes.
So one thing, coming back to your question, how to encourage more students working on, routing, right? I think routing is a very fundamental technique if they learn how to use it. Right? For example, this semester I'm teaching a physical design automation class, right? One of the coding assignment, I'm asking them to implement A-star search, maze routing kind of thing, And of course, my TA, is fantastic. He already provided a lot of baseline code, and so students don't need to write a lot of code. 100 to 200 lines. They could Python. They can do it, right? I think I told the students, hey, if you know how to do maze A-star search, there's definitely jobs for you, right? So I'm pretty excited. So
that's a good idea. Like how you get them like into the problem with a simple, trying to be a simple idea so they can resolve and then get excited. I think that's pretty good. how you are encouraging them.
Right, of course, there's hopefully the companies will have more intern, and as Wen-Hao said, hey, pay routing people more people are working on it, right?
True. Yes, I saw Lalip was like more internship jobs, and as far as I know, like Cadence has several openings, and I'm pretty sure other companies as well like have several internship jobs. So yeah, I think if you have students, you can send to us their resume. We are very glad to get them.
I think a lot of them are online too. So
yeah,
they heard you.
Yes. So yeah, that's good. Like I'm pretty sure like Cadence, Wen-Hao like is in PCB routing. I'm in global routing. There is also detail routing. I think there are some attending the session. Like all of those are looking for interns and new hires. So yeah, we are pretty open for opportunities. Hey, Thiago, you can ask your question.
So I think we all agree that the contests are good, right? Both from academia side and from the industry side. So one question that I have that is more kind of to bring up ideas is that what will be needed in a contest so that we actually do a step forward in terms of methodology, right? How to set up a contest for the industry side people, maybe more, and the professors as well, in a way that we can actually evolve to the kind of maybe a large step forward in terms of algorithms and the kind of solution, instead of just being, somebody is 0.5% better than the second place, and that is 0.5% better than the third place. So kind of to have maybe a paradigm shift or a paradigm change from the current methodologies into something quite different and much better.
Like instead of just checking the results, something more like on the ideas, you mean?
Yeah, more on the ideas, how to set up in a way that is easy enough and generic enough so people can focus more on the algorithms and maybe don't depend on third-party tools or interaction with third-party tools and industry tools. Like for instance, in the gate sizing that we work together, there's a big dependence on timing analysis.
Yes.
So how can you set up something that provides them, provides the participants to focus more on the algorithms and not on the, don't keep it stranded to current technologies?
Yeah, to me, like, I think you need to have like the environment set up. So many people working on the benchmarking and in the environment to be able like to have like already in our case, it was a timing analyzer that was trustable, but also like open source or something that can be, you don't need to depend on those, but others can comment, please.
It's hard, right? Set the goal higher, say higher goal. I think that's the only way you can do it, right? I mean, so that you want something really innovative.
Yeah, I think this will be a very hard challenge for the context organizer as well.
Yes.
Actually, from my opinion, in the recent year, since recent 5 or 6 years, the major challenge in industry is also integration. I think we see more and more tools integrate together and in order to achieve co-design. I think co-design is also a challenge and a research topic. Placement routing co-design, placement synthesis co-design, and package IC co-design. So Tiago, and yes, I understand there's a pen if we want to there's some dependency between different tools, but this is also a pen for us. Now we need to do the cross-domain research. Like me, I was doing IC routing, global routing, digital routing, but now I'm doing package, and even I also need to integrate package router with digital router, even other tool. For example, now even our integration is even beyond EDA. For example, when we implement 3D IC, we need to simulate the thermal, the air, how the air goes for the entire system. This is a recent Cadence in recent year by several non-EDA company. Cadence bought some simulation, some mechanical simulation company last year. Like I forget the name, but anyway, now integration is happening, so it's a challenge for industry, and so probably because of this reason, when industry people host contest, sometimes we also need to play with other tool to get into this integration environment. Yeah, so I'm not sure I answer your question, but integration is also a challenge. Sometimes co-design can also be a research topic.
Yeah, thank you, Wen-Hao.
Thank you.
Yeah, I think the question is very good, and it's for us to think about this challenge. Anybody else has a question or a comment?
I have a quick question for Wen-Hao.
Yeah.
Okay. So, Wen-Hao, right, for your PCB package routing, etc., right? So signal integrity is a very important problem. So when you are doing those kind of routing, right, do you have to run simulator pretty closely with the routing, because that could be pretty expensive?
Yeah,
right?
if we run it very closely, yes, there's trade-off. If we run it very closely, there's runtime overhead. So we need to have some iteration, back and forth, get some do the correct by construction method. So yes, to get entire flow working. We put our router with simulator, actually we put almost everything together in our new 3D IC solution. It includes Innovus, Genus, Allego, our package PCB tool Allego, and the simulator. I'm not sure I answered your question, but
okay.
Yes, we need to do the simulation.
All right.
Nice, great question. I think we are on time for the session. I really want to thank you, everybody, to be part of this session. Like, I know for Yih-Lang and Evangeline is late. For Stephan is getting evening, I think, probably.
2 o'clock.
Oh my gosh, I'm so sorry. Yeah, thank you so much, because I know like it's not easy and you have a work day ahead. So really appreciate your comments, like answering our questions, give us a little about all of this knowledge you have and sharing with us. I think like it brings a lot of ideas and a lot of things we can improve. And if you have any questions, like feel free to send us email, like contact us. Yeah, thank you so much for your attention. Thank you for the disponibility for coming to this session. Thank you.
Thank you.
Thank you.
Okay. Thank you.
Thank you.